For our first presentation this morning, I would like to introduce Brenna Mead, who will be presenting SCinet and Women in Networking at Supercomputing 23, Transforming the Network Landscape. This is a presentation that I specifically asked Brenna to do because someone from Cisco had proposed a talk about setting up the network for Cisco Live. And I was like, wait, I know something way cooler than Cisco Live with a lot less Cisco involvement. Brenna is a senior network architect for international networks at Indiana University and has traveled to us today from Denver, Colorado. It's her first time presenting at NANOG, and it's a pleasure to have her speaking with us today. Welcome.
Okay. Hi, everyone. As she mentioned, my name is Brenna Mead. I actually wear several hats in this community. I'm the Senior Network Architect at Indiana University. I'm also the Program Director for WINS, Women in Networking at Supercomputing at Indiana University. I was the Network Research Exhibition and Experimental Networks Chair for the Supercomputing Conference last year, and I will be the Technical Director for the Supercomputing SCinet Network this year. So today I'm going to talk a little bit about SCinet, and then I'm going to go into a little bit about WINS towards the end, which is the program that's near and dear to my heart, and I'll go ahead and explain why in a bit. So SCinet is the internet infrastructure that is built for the Supercomputing Conference. The Supercomputing Conference has been around for over 30 years. The SCinet network has been around a little less than that. The SCinet network is two distinct but interconnected networks built by volunteers and with donated equipment. So none of the equipment that we use to build this network is owned by SCinet. It is all donated by contributors. So we have a production network, so that provides wired and wireless internet access to all exhibitors and attendees at the conference itself. And then we have the research network. The research network is what's a little bit more fun and a little bit more interesting about SCinet. So the research network supports the Network Research Exhibition and the SCiNet's experimental network projects. And I'll go a little bit more into what both of those are in a bit. We use this saying a lot. SCinet takes 1 year to design, 1 month to build, 1 week to operate, and 1 day to tear down. It's actually more like 4 days. So we build this network for 3 weeks, and it's up for about 4 days. For those of us that work on the network, teardown is always a mixed feelings. Lots of emotions on teardown, as we've spent 3 weeks troubleshooting, building, working with contributors, finding bugs for the network to be up for 4 days, and then we tear it all down in 1 day. So what is different about SCinet? Why participate in SCinet? Why do we do SCinet every year? First of all, it provides a hand-on experience with cutting-edge technology. So the contributors that donate to us are sending us their new gear. We're working with those contributors to do bug fixes, to use their latest and greatest technology to build this network. So many years ago, we had the first Juniper 400G switch. We did some 800G this year. So we're always trying to get the contributors to give us their latest and greatest. You get to build a network you not only build a network, but you also build a network of engineers from industry and R&E that you can reach out to at any time. I cannot express how often I use my SCinet connections to do things in my real job and to make new connections. It's also a ginormous interoperability test because it's all donated equipment. You know, it's not just Cisco, it's not just Juniper, it's not just Arista. It's everybody and anybody that wants to participate and donate into this infrastructure. Going along with that, it's an incredibly diverse set of hardware vendors. There is an architecture diagram later that I'll show, and you'll get a really good feel for how diverse our contributors are and the interoperability testing that we're able to do. So these are the technical teams in SCinet. SCinet is 209 volunteers last year, so over 200 people work on this network for 3 weeks, and then really all throughout the year. For example, I already have a supercomputing, an SC24 meeting next week for the conference that's in November. So we have architecture, interconnection, so they design the network, DevOps, routing, WAN transport, wireless and edge, experimental networks, fiber, and network security. So each of those teams has an average of 15 to 20 people, and they are the technical teams that build this network. We also have several other teams because, as we all know as engineers, we can't do it all alone. We need communications teams, we need contributor relations and logistics, volunteer services, finance, physical security. This is millions of dollars of equipment that we work on, and so security is very important to us, not just cybersecurity, but also physical security of that hardware. Digital experience, so making sure that the virtual attendees have a good experience, the help desk, and then the network research exhibition. So this is the SCinet team. That's all 209 of us, well, most of us. As you can see, it's a large team. It's a huge endeavor. Behind the folks in this picture is the SCinet NOC, which is where all of the hardware that was donated to us and configured for supercomputing sits for the 4 days that it's a live network. So this is the architecture diagram I mentioned, some things I want to make sure that we focus on. If you look, we have a number of internet providers. So we have Verizon, Lumen. Because it was in Denver last year, we had FRGP, Front Range Gigapop. Internet 2 continually provides a significant amount of contributions to SC every year, ESNet, and then Zayo. So just from that, I don't know many areas where you see that many contributors, that many telecom providers working together to support a network like this. And then as you come into the network, we have Arista, Ciena, and also we and Cisco all providing WAN gear. Something that's very interesting about this architecture is it all runs through what's called a Pilatus, so it's a layer 0 optical switch. It makes it so we can connect everything to the Pilatus and do all of our cross connects in software instead of physically moving fibers around. This is incredibly important when it comes to testing WAN circuits. So this year we had 16 400G circuits, and I'll go through a bunch of other cool stats about this, but we had 16 400G circuits, and we need to test every single one of those, and they need to test 100% clean in order to facilitate the type of connectivity that these researchers need to do their DTN testing, to do their large data transfers, to do their LHC, CMS, Atlas experiments that they do on the show floor. So we test every single circuit till it's 100% clean. And that used to be sort of a terrible process, but with the Pilatus, because we can change things in software, it's been an incredible addition to the SCinet network. I worked on the SCinet network when we didn't have the Pilatus, and it was a very different experience. We also have, as you can see, we have Gravwell, we have Juniper, we have Palo Alto. So just taking a look at this diagram, you can see the level of diversity we have as contributors and the scale to which this network is in terms of interoperability. I mean, we have to work with all of these vendors to make sure that their connectivity works with each other. And it's an incredible experience. I admit there is a lot of troubleshooting that goes into doing this, as sometimes we have optic issues, we have genuine interoperability issues between, let's say, we had some issues between Ciena and Arista last year. We were able to work through those, and it's a really incredible experience. If anyone wants to talk to me more about this diagram or get a better copy of it so you can take a look at it, I'm happy to provide that to you. So I just wanted to show, this is what the SCinet network looks like when it's all in boxes when we start. It's from the ground up. The only thing that we have from the get-go is those racks. Everything else we put in the racks, we do all the fiber, we do all of the rack and stack, we do all the power, we do all the infrastructure for this network, both the research network and the exhibitor network that we provide. This is a map of all the connectivity that we provided this year. We have a lot of international partners, so we make a significant effort to connect to international exchange points such as Seattle, LA, New York, Washington, DC, and Miami. These are to facilitate some of those experiments coming from CERN, coming from researchers around the world. And so all of these connections are also donated. As I said, nothing is persistent in this network. So we had donated connections from ESNet and Internet 2. They donated a significant amount of connections this year. Lumen provided connectivity to Miami, which was incredible this year. That facilitated our ability to work with some of the researchers in South America and make sure that they were able to participate in the network research exhibition that occurs every year. And we also used Internet2's connections between their exchange points that are coming up. It's called the NA-REX project. And so this is incredible. Each year we reach out to these vendors, these contributors, and essentially beg them to help us get to these exchange points from whatever city this may be in. So it was in Denver last year. It'll be in Atlanta next year. And we're going to go out and do the same thing, is reach out to Lumen, reach out to Verizon and say, what kind of connectivity can you provide me to these cities, and at what bandwidth? So 100G, 400G, we're looking to do 800G this year. So it's an incredibly challenging task to convince all these contributors to work with us, but in the end, the contributors find value in it as much as we do. And I think for those of us that know these contributors, we're incredibly grateful for their assistance every year. So this is the SCinet NOC. This is where, again, this is all the equipment that we started from scratch and put in these racks. There's over $50 million of equipment sitting in this rack, which is why we have the physical security team. As you can see, there's a number of contributors that I haven't mentioned across that banner. So we have Peer Group, Aruba is also a contributor. We have a number of other smaller contributors, Expo, APC. So as I said, and I will keep saying, it's an incredible interoperability test and an incredible test of our ability to coordinate these different contributors and make sure that we can create this network each and every year. So I want to go over some pretty cool things that we did at SC23. We delivered 6.71 terabits per second to the Colorado Convention Center from those providers that I just mentioned. We had 16 400G connections, 28.7 kilowatt power draw, 206 SCinet volunteers, $40.5 million in donated and loaned hardware, software and optics from over 30 contributors, 12 plus miles of fiber deployed. We have our own fiber team that runs all the fiber on the show floor, and that takes about 3 weeks as well. And then we had 421 access points deployed. So it's quite the endeavor each year that we do. We did a bunch of really cool things this year, or at least different for SCinet. We had a huge effort to do IPv6 only. So that was on the wireless, on our management networks, on our internal networks. I will say that we were relatively successful. We ran into a few things that we needed to troubleshoot and things that were hard to overcome. We will be coming out with a white paper here this year to talk about our experience trying to deploy IPv6 only, including transitional helpers like DHCP option 108, NAT64, and DNS64. We will be continuing this effort into the next 2 or 3 SCs as we try to get our wireless to be IPv6 only going forward. But we did have some issues with VPNs and some other things that hindered us from completely being IPv6 only this year, but we will continue to pursue that endeavor. We also had Verizon 5G on the show floor. They participated in a number of 5G experiments with DOE, with ESNet, and with some other contributors on the show floor. 400G ZR+, and we tapped the Internet2 commodity circuit using 400G ZR+. This was new for us. NSO orchestration and automation with eVPN and VXLAN. We've actually been working on this automation and this LSO orchestration and automation for many years. We finally got it to a point where it's working well for us and that we're able to use it effectively each year. It's pretty incredible. We tapped 8.04 terabits of traffic, LAN and WAN. 2x400, 800G optics between vendors. Multi-vendor zero provisioning. We worked on RPKI this year. We got it to alerting, but not dropping. We will be focusing a little bit more on that this year as there's a general push in the community to work on RPKI and push forward on those initiatives within, especially the research and education community, but also in the general community. Fabric, we had a Fabric switch in SCinet this year. For those of you that don't know, that's a network provided by SCinet to connect research to each other over this Fabric network, and we had a Fabric node at SCinet this year. Automated black hole routing with FlowSpec via Gravwell and Carrero. And then this year we took on quite the endeavor. We redid our entire database for physical and config data. It's called iNext. In the past we were using just a basic sort of wiki, and we moved towards this more automated iNext platform. It was very challenging. But we were able to get through it this year, and we're excited to continue using it and to continue upgrading its features as the years pass. We had 30 published abstract submissions from researchers. We had 18 network research exhibition presentations at the SCinet-sponsored exhibition theater. So this theater was an opportunity for the researchers that come and do experiments on the show floor to talk to attendees in our theater about what they did, what their results were, and how SCinet was able to support them in their endeavors. So that was new this year, and we will be continuing that theater so that researchers can showcase what they're doing to not only the attendees, but also SCinet itself. You know, sometimes as engineers, we build the network, but we aren't exactly paying attention to what it's for because we're just so busy making sure it works. But this gave our SCinet volunteers an opportunity to get to know the researchers, get to troubleshoot with the researchers, and get to understand why we're building this research network for them and why it matters. We did a WAN stress test. Sometimes we've called that the blow the doors off event. It's where we try to throw as much traffic at the convention center as we can. Over 6 terabits per second combined in and out this year. That was a record for us. One of these days we'll get up there all the way to as close to our max as we can. We try not to flood the commodity networks, however, so we try to be careful when we do this WAN stress test. This is just a diagram from the WAN stress test. As you can see, we do it on the last day of the show during a set period of time. So between 1 and 2, we have you throw as much data as you can at our network. It's also a stress test for our network security team, for the routing team, and also for the WAN team, just to make sure that all of our equipment is performing efficiently and in the manner that we expected it to in this stress test. This is very important to the researchers as they really like to see what they can do, if they can break our network, if they can flood it, if they can, how high they can get it to be. So it's really an incredible time, and the researchers really love participating in the WAN stress test. So now I'm going to go into women in IT networking at supercomputing. This program is near and dear to my heart. I was a WINS awardee in 2018. I'm now the program director for WINS 6 years later. WINS changed my life, so I'm going to go ahead and give you guys an overview of what it is. So the Women in Networking at SC WINS program was a multi-year funded NSF program developed to address the prevalent gender gap that exists in information technology, particularly in the fields of network engineering and high-performance computing. Admittedly, we still see it in this room. And so we saw it in SCinet. There were members of SCinet that noticed that there was a extremely low number of women volunteering for SCinet each year. And so this program was developed to address that. So WINS funds 3 to 8 women per year to participate in SCinet. To participate in SCinet, you have to travel for essentially 3 weeks to wherever it is. So last year it was Denver, this year it would be Atlanta. So we provide funding for their travel, for their lodging, for food, and for any other sort of miscellaneous expenses that they may incur as a result of participating in the program. The women are selected by a committee of experts that are rigorously reviewed and evaluated each year. And that selection committee is full of members of the community, members from SCinet, from industry, from Internet 2. And so it's a very community-driven effort, this selection committee. So it gives these women, as I said, the opportunity to work with some of the best network engineers and software engineers and HPC engineers in the world, and some of the best network technology vendors in the world. It's a hands-on internship that is just an incredible experience. Once you go through the program, we also fund WINS participants to attend conferences such as NANOG, the Internet 2 Community Exchange, other conferences like that so that they can get even more introduction into the community and to meet more network engineers and more and career developers. We have quarterly alumni meetings, and we also allow our WINS alumni to participate in the More Leadership Program. For those of you that know what that is, it's a program, it's a year-long program that has cohorts and works with people on leadership development. It's an incredibly good program. So we've had an incredible impact on SCinet. The percentage of women participating in SCinet has increased significantly since 2015 when we started the program. In 2007, 15 of the 105 volunteers were women. In 2022, 41 of our 179 volunteers were women, and 17 of them were from the WINS program. We also have seen, because we are doing such leadership development and cultural development, we're seeing a lot of our WINS women go into SCinet leadership. I'm both a great example and a terrible example because now I am leading too many things. But the percentage of women in SCinet leadership has grown from a low of 8% to 15% for SC22, so that's almost double. Women from the WINS program have started assuming SCinet leadership roles in 2017, 2 years after the program began. And for SC22, 6 WINS awardees had leadership roles. For SC23, 13. So this is just a visual of that. So we have, the percentage of women in SCinet leadership roles. We are seeing some impacts, I think, as we all are, from COVID. So in the program, we're bouncing back as each year, but we did see a significant drop in applications and in people participating in SC21 and SC22. SC23 was a little bit better, and SC24 is already looking better. Contributors to WINS include ESNet, Sienna, Indiana University, Internet2, Juniper, Northern Tier Network Consortium, Pacific Northwest Gigapop, and the Quilt. We are always looking for additional contributors, people that want to work with us in this program. So if you have an interest or you know someone who may be interested in contributing to the program, working with us, we also invite speakers to talk at the alumni meetings about their career and how their career developed and things that helped them in their career and advice and things like that for the women that go through the program. This is us from last year. This isn't all of us actually, but this is most of us that participated in SC23 last year. It's an incredible group. As you can see, we're working on diversity in all areas. We are targeting underrepresented institutions, underrepresented universities, minority serving institutions, TCUs, and so we have a lot of members from specifically TCUs and minority serving institutions that are participating in WINS. The applications for WINS went out in December and they closed at the end of January. We have over 25 applicants this year, and we will be announcing the participants for WINS this year at SC24 in the beginning of March. So be sure to look out for that announcement. This QR code is actually broken, but if you have any team members that are interested in participating in SC24, if you are a contributor that would like to get involved in SC24 through donation or participation in SCinet, please let me know and I can get you in contact with the right people to get you involved in SCinet. I cannot speak more to how much it has changed my life, my career, and it has grown my network in a way that I don't think any other leadership program, internship program I've ever done has. And for those of you who have women working for you or around you that could benefit from WINS, please come talk to me. I cannot express enough how much WINS changed my life. I would not be standing in front of you without the WINS program. And we want to be able to give that experience and that opportunity to the women that you work with and the people around you. So please, reach out to me if you are interested in doing that. And that is time for questions.
Hi, Jason Bodie, Moody's. Is the WINS program open for applicants only in R&E world or outside of R&E?
It's open to anyone.
Okay, thank you.
Hey, good morning. Sorry, I'm a little too close. Since you're just dealing with donations with all the different multi-vendor hardware, did you have any volunteers that came in that were like really dead set on a particular vendor, really hated one, and just having to deal with what you were, the cards you were dealt, that kind of opened them up and they, considered some different vendors or technologies they might have dismissed before?
Absolutely. I won't mention vendor names, but
No, that's fine.
we did have. We've seen some members of SCinet come in and think, oh, I would never use that. I'm a Cisco person, or I'm a Juniper person, or they come in with sort of their ideologies about what they like. But it's such a fast-paced environment that it's really hard to get stuck in your ways. It's like either you make it work or you tell somebody else to do it, because we have to build this network in 3 weeks, and it always comes down to the wire. Just because it's such a large infrastructure to build. I will also say there was an interesting story from our current SCinet chair. She participated in SCinet and started using some Arista gear, and then the university that she works for ended up going out and doing an RFP, and Arista had never been even in the mix on RFPs at her university, and then because of her experience at SCinet, she reached out to them and they ended up in the pool, and I believe they actually got the contract for that university. So, and we've had other stories like that with Juniper, with Aruba, and so I think because it's such a fast-paced environment, you have to learn it or you have to move out of the way. And so most people don't move out of the way, they learn it, because all of us are engineers and this is what we love, and most of us are excited about that challenge and want to learn something new. And that's the whole idea. It's a hands-on experience. So, if we know you're a Juniper person, we traditionally say, go work on Palo Alto, go work on Cisco, just to give you new experience and make sure that you have the learning experience that we're hoping that this experience provides.